mix the material, that ties up the water, stabilizes the material, adds some strength to the cover system that was designed for it, and that process will be then to give that to the NRC and say, using this closure process, there's not going to be a measurable dose from this closure. And they'll look at it and they'll say, yes or no. That's the process that we're going to go through. And we've started the process.
This closure procedure that you're fixing to do, what about the integrity of the liner that's under the pond?
In the NRC's evaluation, they would have concerns that somebody else raised this question here. What about the length? What about the longevity of those liners? NRC processes, they look at those and they say, we don't let you take credit for those because how do we know they're going to be here 50 years from now or 100 years from now? So the dose evaluation that we did, that we gave to the NRC, basically acts as if it's not there.
Like the liner's not there?
Like the liner's not there.
Like a worst case scenario.
The NRC always wants you to look at things conservatively, so they would treat it as if there's no liner under the pond.
Yeah, well,
None.
I want you all to understand that the reason that we're so concerned about this is you go west of E-Pond, you know there's a huge draw there. And we all know where that draw runs to. It runs directly to the river.
Okay.
So any leaching that comes out, if you look at the slope of the land, that's where it's going to go. It's going to go to the river. That's why it's a big concern of ours around here, because a lot of us that work inside that facility know what's in those ponds. We know what's put in those ponds. What used to be, I should say, what used to be put in those ponds. And it's a major concern of what's going to get into the water system around here. That's a huge major concern.
Right, and currently, as part of the permit from the EPA, they're required to do regular groundwater monitoring of the uppermost aquifer, which, depending on season, may be 40 to 65 feet below the surface. The wells get sampled 4 times a year quarterly, and the wells will be have been sampled, throughout the pond's operating life or kind of quiet sitting their life today, and they'll also be sampled into post-closure once stabilization's done and the ponds are all covered. The groundwater will continue to be monitored, and the results, they're all required to be reported to the EPA. If there's an exceedance, an increase in concentrations, downgrading of the ponds closer to the river, then, there hasn't been anything like that. It's all been just kind of what the EPA calls routine monitoring, because there's nothing showing up in the groundwater. If there was, then at that time, we need to take additional actions to ensure protection of the groundwater.
But
That's not something that they'd be able to get on.
when Metropolis Planet publishes the water testing, the required water testing, which I don't put a lot of stock in that anyway, when they do publish that annually for Metropolis, they always find some alpha. And it always says naturally occurring, but you look at the samples for like Fort Massac water and Millstone, and they don't show that. I just think that's kind of curious.
I'm not familiar where, the city of Metropolis would take the samples, or where they would take their samples from.
They're required to post their water samples on a periodic basis,
Sure.
just like every public.
Daily, we check the wells around there for the leached water. When you cap this, currently we pump the water back into the pump. Where are we gonna go with it now?
Into EPF.
So you're gonna pipe all of the wells to EPA?
In the short term, but once the ponds are stabilized and covered, the amount of water is going to decrease. So over time, you won't have any water generated.
So what's the difference
We're
in?
talking about the monitoring well, the north can be water is monitoring water.
Yeah,
The
those
monitoring
are
wells
deeper.
would continue to be monitored, and the sumps, that are drained daily right now.
Right.
The sumps will continue to be drained. However, that material, rather than being returned to the ponds, will go to EPF for treatment.
For treatment.
a two-part question. I'll give them both to you related, and then you can answer them whatever order you want. First part of the question is, previous studies indicated, and we were told for a long time, that before closure of the ponds could be completed, there was over $1 million worth of U in those ponds that the company wanted to reclaim. And of course, the value of that U just continues to increase. That's why they wanted it, not because they wanted to get rid of it before they closed the ponds, but because they wanted the monetary value of it. Are those studies in conflict with what your analysis has shown? And then the second part of the question is, what is in those ponds, material that's in there? Lime is used as a stabilizing agent. That's not long-term. What is the effective lifespan of that lime as a stabilizer?
I'll try and answer your first part of the question. I'm not really familiar with what studies or testings Honeywell is going to see about recovering the material, the uranium out of the ponds. But from discussions, from what I understand, the amount of uranium in the ponds is too low to give any value to recover, that there's simply not enough to recover out of the ponds.
Whose decision was that? Who's saying it's too low?
I
Your-
don't know that decision.
And about the lime, what's the effective lifespan of lime as it's used in this application as a stabilizer?
Well, the stabilization of the material itself would be with Portland cement or something like a Portland cement. It wouldn't be with lime per se. It's going to be with something that's going to create, basically going to take this material, which is currently very soft, as you're aware, it's got a high water content, basically bind it up and form a solid that's going to pass the strength test equivalent to like a strong soil. And so that's going to have a relatively long strength. It's going to basically be like a cement. It's going to have a long-term lifespan. And we're going to do treatability testing. We haven't finished yet. We're going to do some treatability testing to try and determine what that mix of cement has to be to make this stabilized material actually strong enough to be stabilized long-term. So we haven't actually selected the actual stabilizing agent yet. It's probably not going to be lime. It's going to be Portland cement, something like that.
Has this been tried before?
Stabilizing with cement and other types of additives?
Yeah.
Sure.
Where?
In this application?
Specifically this type of application,
Yes.
meaning for surface empowerment coating?
Yes.
I actually don't have information on that myself right now.
So that's a no.
It's not, no.
That's a no.
It's a no.
It's an I don't have that information right now.
I have a question. You said, how deep did you sample into the ponds? You said you were only able to go as deep as your probe would go, but did you go all the way to the bottom?
In some of the square locations, like out in the middle of the ponds and kind of towards, say like B or C pond, where the deep end, is towards the eastern side of the pond. Those areas we were getting going up maybe 15 feet.
How deep is the pond?
They vary from about 14 and a half to 16 and a half foot. They're kind of sloped at an angle to drain things.
So you didn't go all the way to the bottom?
Well, like I said, in some areas we got down 15 feet of material out of the ponds.
Some areas, but not all areas.
Not all areas, you're right, because I
Okay.
mean, as you know, the slope of the ponds, it's not a box. The stuff is kind of sloped on the side, so like the locations where we sampled, like along the shoreline of the ponds, we might have only gotten 4 feet down, because,
So, but uranium being heavy, it's safe to say that the higher concentration is going to settle towards the bottom of the pond.
I don't think the sampling results really showed that, like the samples lower obtained, I have to double check, but I don't think they showed that there was a bias, like higher or low.
Well, we have settling tanks
Right.
all over the plant. That concept is used every day. You settle the solids that had U in it, settle at the bottom, and we drain the water off the top. So, I mean, U is a heavy metal. I mean, just to follow up on his question. So, what you're saying is that no, you don't think the U is settled down on the bottom because your data is not reflecting that, and is your data not reflecting that because you're not able to go all the way down to the very bottom?
Well, the material, like I said, I don't think there was any, like the lower samples varied discernibly or, too much from the higher level samples. Or say in the lower samples, we didn't see very much higher U concentrations. When we were doing the sampling, we tried to push the probe down as deep as would allow in the location. But, we didn't want to impact the EPD and liner under the ponds. We didn't, they weren't out there, pounding on it to get it to go down. I mean, they made some physical effort to get it down, to get as far as it could go. That's was the sampling method.
So Honeywell has the facility there to process calcium fluoride at the EPF facility. And they do it now. And we're assuming they're going to do it in the future because if you're going to eliminate these ponds, there's nowhere for it to go. They have to process it. Why can't they process what's already there the same way and eliminate it? And why are we going to mix it with cement to now where we have a solid that has to be disposed of, because the environmental regulations are not going to get any easier as time goes by. We're going to create a solid where right now we have something that can actually be processed. The liquid can be, the facility exists already. Why would we want to make it a solid and grow grass on top of it? And where nothing can be built there, and I heard you mention earlier, you just basically notify the next owner of the property that, nothing can be built there. Why, it sounds to me like this is the cheaper way to deal with it for right now, with no forward looking into the future. And I'm not talking about 100 years, I'm talking about 20 or 30 years. Why aren't we getting rid of it? Why are we turning it into a big piece of contaminated concrete?
Well, it was evaluated that, there's always various options for anything they can do. And it was evaluated that closing the ponds in place by solidifying it and putting a multiple layered protective cover system over it would be protective long-term for human health and the environment. And that, for the EPA and the NRC, that is the decision thesis. Is the closure going to be protective of human health and the environment?
How thick is the liner underneath this? And the liner's not going to change. I'm assuming the liner is going to be what exists there now.
Right.
And is there data to suggest once you put a solid on top of that liner and you've got ground underneath it, nothing is going to, this concrete, even though it's going to be a fixed piece, there's not going to be any expansion or contraction through the seasons. It's not going to deteriorate that liner in a short time. Like I said, I'm not talking about 100 years. I'm talking about the next 20 or 30 years. What kind of data? You said this has been used before in other applications, and it hasn't ever been used at a conversion facility because this is the only one. So what other applications have you used it in, and is it the same kind of materials that you're willing to say, we're all going to be safe, that nothing is going to leach out of this liner, that there's going to be no way to check because you put concrete over it unless you dig to the other side? What kind of data do you have to suggest that this is going to last even 20 or 30 years, much less 100?
Well, for ongoing, post-closure, we talk about other facilities, but Honeywell currently monitors the moisture in the soil beneath the soil part of the liners. They currently in the lysimeters, if you probably see them around out there. They currently monitor those quarterly, and quarterly monitoring will continue. They currently drain the sumps, drain the liquids out of the sumps, and the draining of the liquid out of the sumps will continue. They currently perform groundwater monitoring of the uppermost water-bearing unit around the ponds, and that will continue.
What's the contingency if the samples come up high? How will you repair the liner once you've got concrete on top of it? Is there a contingency in place, or are we just dealing with this for the now?
That's been thought about, yes, and it's
Shouldn't it be